Okay, guys, part two. We've just found that FBC is in 0.875 kilonewtons of compression, and we did that by summing the forces in the y direction by realizing that the other two forces are not acting in the y direction at all, so we could get away with that with only the one unknown there. Alright, so now we're going to do some balancing of moments to get these other two going. Okay. Now, if I want to, I've actually got one of the unknowns now. So I could technically choose a point to balance my moments around that will just eliminate, if let's say I'm trying to find FBD, I could just eliminate FAC, and I know FBC, but it's still going to add to my maths. So what I'm going to do is I'm going to do what we've always done, and when we have a non-concurrent problem like this, we're going to balance the moments about a point that cancels out two of the forces, so I don't have to do any maths even if I happen to know one of them. So we're going to balance it around point B because FBC and FBD both run through that, and I'm going to use that to find FAC. Alright, so here we go. So I'm going to sum the forces, sum of the moments, about point B must equal 0, and because it's in equilibrium, sum of the moments about any point must equal 0. So we got clockwise equals counterclockwise. Clockwise about point B, we've got our RAY, and it's acting at a perpendicular distance. Remember, we have to imagine this force acting in this direction. Perpendicular distance is that distance there, which is 0.6. So we have 14.25 times a perpendicular distance of 0.6. That is the torque there. Anything else going in this direction? No. Just FAC is going in the other direction. These two forces run straight through point B, so they have no perpendicular distance and therefore will not produce any torque. So we have FAC here. FAC times a perpendicular distance. Well, the height of this truss is 1 meter, so that distance there is 1 meter. And that is also the perpendicular distance to that force. It's acting in that direction there. All right. So this is times 1. Now, some of you might be thinking, what about RAX? Now, you'd be right. If this had a value, then we would have to include it. But I know it doesn't have a value because before we broke anything up, when we're looking at this from the macro scale, there was no horizontal forces acting on this thing at all. The only thing acting on it was RAX, so it's got to be 0. So when I sum the forces in the x direction of the entire truss, RAX must be 0. Now that might not be the case if we have angular point loads on a truss, but in your syllabus, it says that the truss problems you guys have to deal with only deal with vertical point loads, not angular point loads, okay? So don't worry about that. RAX is always going to be 0 for your problems. So that's a big fat 0. All right. So this is a very simple balancing moment problem, when mathematically anyway. If you get how to figure out this perpendicular distance from all of these forces, it's not going to be causing you any trouble. So it's going to be FAC literally equals 14.25 times 0.6. So it's clearly going to be in tension because this is going to be a positive number. Let's put that in. 8.55. Kilonewtons. And I would write, therefore, FAC under 8.55 kilonewtons of tension. And I would underline that as my answer. Okay, so we've found that FBC was equal to 0. FAC was 8.55 kilonewtons of tension. All right, too easy. Now let's find our final one, FBD. We could do this a couple of ways. We could choose point C here and balance moments again, or we could sum the forces in the x direction. Now, I actually think balancing moments might be quicker and easier because we won't have to deal with FBC, which is an angular load. We don't have to worry about finding components or anything like that. If we just balance the moments about point C, we're going to have something like this. You see how simple this problem ends up being? Very, very simple. So let's get rid of all this and we'll do it again. We're going to do it about point C this time, which is, in this case, it's a theoretical position where FAC and FBC would be intersecting, but that is literally where the members do intersect on the truss anyway. Okay. Now, so it's going to be right there, 1.2 meters away from A. Let's get it started. Okay, so sum of the moments about C must equal 0. So clockwise equals counterclockwise. Now I should be writing sum of the moments clockwise, blah, 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 but you know this is paint does my head in. So clockwise from C, we have RAY, and its perpendicular distance is that 1.2 meters in between them, because that's a right angle there. So that's 1.2. And we also have, going in that direction, we also have FBD, which is our unknown. FBD. And it's at a distance of, well, the distance between C and FBD is, there's the perpendicular distance there. That's the height of the truss, which is 1 meter again. So times 1. We have nothing else because FBC and FAC both run straight through point C. We don't have to worry about them. But we also have that 15 kilonewton force that's acting in the counterclockwise direction. So we got 15 times a distance of half of this length, which is 0.6. So again, it's a very easy mathematical problem. I haven't eliminated the 15 kilonewton from my equation, but that's fine because it's at a right angle, so there's no components to worry about. So if I solve all of this, FBD, our one unknown, is going to be, because we know RAY is 14.25, it's going to be, I'll leave it up this time because we have a little bit of time. You can see my calculation. So it's going to be 15 times 0.6, that's the right hand side of my equation. We're going to subtract, that's this bit here, we're going to subtract this bit. So we're going to take 14.25 times 1.2. And now we have to divide it by 1 or do nothing. So we actually have the answer there. The answer is minus 8.1. All right, so FBD, actually a more correct way to put this might be member BD is under 8.1 kilonewtons of compression. All right, so there's my final answer there. FBD equals 8.1 kilonewtons of compression. Done. Now that is it. Let's fill out these steps again. Let's fill out what we did. What we did was we cut the truss to create new free body diagrams. Step 3. Sum the forces in the y direction to find the angled truss. To find the forces in the angled truss. Okay, so that's what we did in the last video. We realized that FBC is the only unknown acting in the y direction. So if we sum the forces in the y direction, we eliminate FAC and FBD from that equation because they're not acting in the y direction at all. So step 4, balance moments about a point that eliminates two forces in order to find remaining two forces, and we have to do this twice in order to find remaining two forces. Okay, so that's a process for you guys to run through. The video is available for you guys. You can watch as many times as you want. The process will always be the same. The numbers will be different. You might have to find different, like you might have to find a different angle here because the truss might be in a different configuration. But the process up here is always going to be the same. Okay? I hope that helps, guys. Much love. Good luck for the test tomorrow and Friday. See you later.